Understanding the water, energy, and food security nexus in the North American Arctic. The North American Arctic is a vast area that extends from the Aleutian Islands in western Alaska to the eastern shores of Labrador in eastern Canada. Despite its geographical expanse, the North American Arctic is sparsely populated with less than 1 million residents, 25% of whom are Indigenous. Communities range in size from nearly 300,000 in Anchorage, Alaska, to as few as 144 residents in Grise Fiord, Nunavut, and exhibit considerable cultural and economic diversity. Despite this diversity, communities in the North American Arctic share the unfortunate condition of having the highest rates of water, energy, and food, known as WEF, insecurity among all Arctic nations. Across the North American Arctic, many residents lack access to basic water and sanitation services, with the highest rates of water insecurity occurring in remote Indigenous communities. In parts of Alaska, the lack of adequate infrastructure and water services have contributed to poor health of residents, including the increased incidences of hepatitis A and B and other respiratory problems. Similar health conditions exist in northern Canada, with boil water advisories becoming routine and lasting for years. North American Arctic communities also experience high rates of energy insecurity. Because of the long distances between populated areas, there is limited grid connectivity. Communities typically rely on imported fuel, mainly diesel, to generate local power. With limited capacity to generate power from renewable sources, communities are overly dependent on external energy supplies. Global fluctuations in energy prices make these conditions all that much more uncertain. Communities in the North American Arctic are also overly dependent on imported foods. Alaska imports 95% of its food at an estimated annual cost of $2 billion. Most food imports arrive by air and water, which are subject to disruptions in global supply chains, transportation delays, rising energy costs, geopolitical uncertainty, and the seasonal and weather-related conditions unique to Arctic environments. In regions such as Nunavut in northern Canada, these conditions have contributed to nearly 60% of residents being food insecure. As alarming as these conditions are, the effects of climate change are expected to intensify existing conditions and create new challenges for communities to meet their water, energy, and food needs. As Arctic temperatures continue to rise, extreme weather events are expected to become more frequent. These impacts are already causing infrastructural damage that hinders the reliable transportation and delivery of WEF services to remote communities while imposing significant costs to the maintenance, repair, and replacement of the infrastructure. To date, most responses to address WEF insecurity in the North American Arctic have been singular in focus and fail to consider the interactions between WEF systems. For example, in some areas of the North American Arctic, there are efforts to increase hydroelectric development in order to generate electricity for remote communities. These efforts, however, put salmon at risk and other fish migrations that compound food insecurity while releasing contaminants such as mercury and selenium into water bodies communities use for drinking water. In other regions, agriculture is being promoted to alleviate food insecurity by lessening the dependency on imported foods. However, agricultural expansion can put additional demands on scarce water resources and often require additional energy input. Agricultural expansion also transforms forested lands, making them unavailable to Indigenous peoples who have long used them to satisfy their food needs through hunting and trapping. Wind power is also being promoted as a sustainable option to non-renewable energy sources, but can have negative impact on migratory animals and is often opposed by Indigenous peoples whose cultural livelihoods are put at risk through displacement. By not accounting for the nexus between WEF insecurity, actions intended to alleviate WEF insecurities often create new vulnerabilities. Given the complexity of WEF insecurity, the Arctic WEF Nexus Security Network was established. The network is an international collaboration launched at the University of Saskatchewan that is set out to promote Nexus thinking and Nexus doing. Nexus thinking is a way of recognizing the crucial interdependencies between water, energy, and food systems in the Arctic, and the cascading impacts brought to bear from climate change. As a conceptual framework, the WEF Nexus is a discourse for problem framing that promotes cross-sectoral and transdisciplinary collaborations. Nexus doing involves developing analytical tools that systematically apply quantitative and qualitative methods to understand the interactions between WEF sectors. By conjoining Nexus thinking and Nexus doing, the Arctic WEF Security Nexus Network is in the active pursuit of WEF security in all Arctic regions. If you'd like to learn more about the Arctic WEF Security Nexus project, please contact David Natcher at the University of Saskatchewan.